A useful rule in mathematics: never divide. As usual, definitions are the whole of mathematics. All else is commentary. So let's consider when we define a division, a divided by b equals q with the remainder r means that a is qb plus r, where our remainder r is strictly less than our divisor, but greater than or equal to 0. So for example, we can find the quotient and rewrite the result, 27 divided by 11. We find that 27 divided by 11 is 2 with remainder 5. And so we know that 27 is 2 times 11 plus 5. Now, this should be pretty familiar. However, there is a conceptual depth to it that we need to go into. So let's talk about the division algorithm. An algorithm is a process for solving a problem that always terminates after a finite number of steps and always produces an answer to the problem. When we compute a divided by b equals q with remainder r, we use a division algorithm. Or do we? The simplest division algorithm is repeated subtraction. So 27 divided by 11 is 2 with remainder 5, since we can subtract 11 twice and leave 5. Or can we? Well, let's see. 27 minus 11 is 16. 16 minus 11 is 5. We could subtract again, so it's clear that there's a little bit more to our algorithm. And when describing an algorithm, it is important to identify all of the assumptions that we're making. So let's be a little bit more explicit. Our algorithm for dividing a by b is to subtract b repeatedly until the remainder is less than b. The number of times b can be subtracted is the quotient, and the final remainder is the remainder. So remember, definitions are the whole of mathematics. All else is commentary. Our quotient a divided by b equals q remainder r means that a is qb plus r, where r is between 0 and b. And the important question is, can this always be done? We'll use a descent proof. So we'll assume a and b are greater than 0. Then clearly, a is greater than a minus b. So repeated subtraction gives us a descending sequence of whole numbers. This has to have a last term, a minus qb, because if a minus qb is greater than or equal to b, we can subtract b again. So we know that this last term has to be less than b, and so we'll let r be a minus qb, and so a is qb plus r, where r is greater than or equal to 0, but strictly less than b. Consequently, this gives us a theorem. For any whole numbers a and b greater than 0, there exists q and r, where a equals qb plus r, with r between 0 and b. And if we tie in our definition, this is the equivalent to the statement that a divided by b is q with remainder r. In other words, any two whole numbers can be divided, leaving us with a remainder.